Good afternoon, YouTube. Today I'm just going to be doing part 4, and in this one I'm going to show you how to write what I personally think is a pretty good skeleton for all sort of like raw Lisp web apps. I did in the last video, give hints on what we were doing when I included Hunchentoot, Spinneret, and ParentScript. However, I did forget to include LAS. LAS is a CSS generating library, so it's like a Lisp to CSS DSL. So yeah, I think that's basically the introduction. So why don't we get to it? We're going to be making TicTacToe a multiplayer game using only Lisp. We're not going to write a single bit of JavaScript or anything. We're going to do it if we need JavaScript, we're going to generate with ParentScript. We need CSS, generate it with LAS. We need HTML, we're going to generate that with Spinneret. And we're going to use Hunchentoot as a server. So let's get going. So what do you need for a website? You need pages. So we're going to def class page. And in our page, we're going to have the title. And we're going to have the accessor title. Init arg title. Init form. TicTacToe. Type string. Documentation, the page title, self-explanatory. And then description, accessor description, init arg description, init form, TicTacToe, the multiplayer version, written with pure CL. And then, I spelled init form wrong. That is also a string, documentation, a pages description, documentation, the base page, a page class for generating per page HTML, CSS, and JS. How about that? That works. Right, now we are going to be using Hunchentoot. So I'm going to make a file called handlers.lisp in package TicTacToe. I will show you how to quickly get Hunchentoot running. So we're going to have our server variable, and we're going to do make instance, tbnl, it's easy acceptor, and now our document root is just there. Our port, we're going to go with 33333. Our address is 127.0.0.1. If you were doing something in live production, I'd probably use 0.0.0.0 because that's all listening on all addresses. But obviously this is just a test thing that I'm running on my computer. Now we have that, we can do tbnl start server. And now if I go to the Firefox I prepared earlier, we can see that we have no handler for root, so for the slash. So let's quickly sort that out. So we do tbnl define easy handler. And now I'm going to code that I wrote previously, of course, which is in handlers. And so we have define easy handler, and then we have the name of our handler, URI, and in this case we're only going to be using get requests. And in this list we would put like get variables. So you could have a variable like name or something, and that would be automatically passed from the string. Now we're just going to return hello world. And now if we refresh this, we have hello world. Very, very easy to get your website running. However, we want a means of having like a page that sometimes is in a like where, well, we actually want a full-blown system where you can check to see that you've received certain variables, and those variables are, you can make checks to see if they are what you expect, and then you can display the page in different ways depending on the sort of the state you receive from the user. So we're going to make another file called HTML protocol.lisp in package TicTacToe. Now, if we are, I'm just going to refer back to what I had previously. Now, if we think about the sort of what we wish to display and how a HTML page is structured, you start with the HTML head, then you have the body, then you have the footer. So let's create a method called Defgeneric, or create a generic function, sorry, called display page that will take a page. You saw that earlier. It will also take a state object. So a state object will be used to, we'll just use that to store variables, referencing like maybe variables we found previously, like the user ID, or maybe in this case the board, and maybe some other things. Who knows? It will evolve, and it doesn't really matter too much what's in it right now because we're only doing the skeleton. And then we'll have methods. Oh, well, actually, we'll write the documentation. Displays a page based on state. I don't know if I've mentioned this previously, but you capitalize the variable, or you capitalize the parts of the string that are referencing passed in variables. But this method, display page state, will use Spinneret with HTML string. So this, quite simply, Spinneret with HTML string. You give it something like this, ABC, returns a string. You know what we did. Div class my div. You see, generates the HTML. Now by default, you'll see in a minute that we do that. Now basically, everywhere else we're going to use with HTML, because with HTML effectively outputs to a stream. Now with HTML string being at our absolute top level, we'll take this stream and we'll convert it to a string, which can then be sent to the user effectively. But we're going to do what I said. So we're going to have two methods: display, we'll have page header, page and state, page body, page and state. We're not going to bother with a page footer because this is actually how I this is how I write most of my web apps, and I don't think I've ever used a page footer yet, so we're not going to bother yet. So we're going to have, I'm just going to, we'll write a page header and a page body, and I'm just going to quickly pause and just do that because it's just writing a lot of doc strings. Right, I'm back. I've just quickly filled out these generics and these methods, and I've given them the defaults. Now we are going to use what is called an around method. So an around method works like this. You have a bunch of code here. You have ABC, and then you have DEF, and basically the around method, if I was to invoke page header with a page and a state, the most specific around method is called, and then it executes this. It then calls the next method, which for this default method combination, which we're using because we haven't specified anything else in Defgeneric, will then call the most specific method. In this case, it would be this one, which would only return nil. And then it would execute DEF. So it literally executes around the body of call next method. So it's a bit weird at first, but you can see that comes in exceptionally handy when you are trying to reasonably complicated systems. So we are going to refer to what I wrote earlier because there is no point in rewriting all of this, but I will explain what is happening. So like I mentioned earlier, we're just using Spinneret with HTML rather than with HTML string because we're trying to continue appending into the stream, which is then eventually turned into the string here. So we have our HTML head, we got our meta, got a meta for description, which is taking variables from slots within an instance of the page class. We've got viewport, we've got the title of the page again. Now, we haven't included style sheets yet. Obviously, if you were to copy this, you can use whatever style sheets you like. Personally, I'm a big fan of the milligram.io. Like it's a minimalist CSS framework that only includes a few things, but it looks quite nice. So, and then here you see we're iterating over this list, and for each one we're appending the HTML that's generated from here to the stream. And then we're going to call a method called page CSS, which we have not created yet. Page state. Now, this is where things get extra interesting. So we are going to use we're not going to use the default method combination. Okay, so we are going to use a different method combination called append. And we're going to use most specific last. And I will explain to you what this does. So, as I mentioned earlier, the default method combination just will call the around method, call the before, then the around, and then inside the around you call the most applicable primary method, and then it calls the afters. Okay, now the difference between that and using the append method combination and other method combinations like plus or progen, the difference is that in the case of using most specific last, you don't have before, you don't have after, you do have around. And so the around, excuse the around, basically when it's called, it will go through the class hierarchy, and from every part of the class hierarchy, it will go from the least specific, it will call the method most applicable for the least specific, then the method for say you have 3, so it does the least specific, then the middle specific, then the most specific last. And in the case of append, it's literally taking a list. So each method returns a list, and then when it's finally finished, going through the class hierarchy, applying every method, it takes the single list that's created at the end and returns that as the final result. And you'll see why that's so useful when generating CSS. So if we do Defmethod page CSS append page state, now this is going to be our it's our around, isn't it? It's around. So we're going to make use of around again, and we'll refer to what I wrote earlier. So we need a style. We need a style sheet. Type text /CSS. Now this is where last comes in. Last compile and write. Call next method. Okay, let me add the default and I will show you what is happening. Now it's very important. You don't want to mess up, because if you if you forget to add the method combination here, which is the append, you're basically going to break it. And it's pretty common to do that. So make sure you don't forget. But in this case, because we are returning a list, we're going to have HTML background color, and we're going to go with gray, and we'll change that later. But this is now our very default. So this is our least specific CSS. Okay, so this is going to be appended to the start in every single instance that we call page CSS with whatever subclass of page. This one will always be added. So that's why this is so important. So if we, and you can see what's happening. So we have our round method. It's calling this. It's then, it's doing this. And now it calls next method, which goes through each, calls page CSS on every member of the class hierarchy, each subclass, all the way down to the very most specific, which is the object you will have passed in. And it will call page CSS, which returns a CSS list, which las is then las compiler write is then called on the list of lists and generates our CSS for us. So it's a very cool way of generating CSS, and you'll see later how useful that is. We won't really do too much with it in this video, but in the next one. Right, so we do need to now, we are forgetting about the state part, so let's just make state. And in this case, state's not going to take anything yet. Oops. Because none of that's necessary. We have good state. Ooh. Subclass state and def class bad state, which is also a subclass of state. And we need a way of determining state, so we're going to do def class. Oh, we're going to do Defgeneric find state page args plist. Now, I like plists because you can do destructuring, bind, key your keywords within your plist. So I don't know, maybe you have your plist. Your plist looks like this. You have A, B. B, well, you can just do key, and then you can just have A, and then allow other keys in your plist, etc. And it just only binds those ones. So I find that very useful. But in this case, we determines the state, the current state for page, given a list of a plist of arguments in the plist. Oh, that's supposed to be a rest. There we are. And then we'll just provide a default def method find state page rest plist, which will declare ignore page and plist, and it just makes instance of bad state. So we have a default, and we can also include in our default, we can do def method page body page and then state bad state. So we'll just provide some default state for when it's messed up. Default HTML, sorry, Spinneret with HTML, which is going to say H1, oopsie, you borked it. There we are. Right, so we've got a pretty decent skeleton here. We've got our methods for building a page, for displaying a page, our headers, a page header, which includes our style sheets. We haven't done any JavaScript yet, but we'll do that maybe in the next video or video after. We've got our CSS. We've got our protocol for defining CSS or per page CSS. So that's good. Let's actually make a page. So let's make a file called pages. Ooh. So we're going to def class main page, and we're just going to inherit from page, and we're not going to change anything. Def class main page good state. Good state. So we're just going to inherit that, and then we're going to do def method find state page main page, and we're going we have our rest plist declare ignore page plist, and we're just going to return make instance main page good state. So in this case, every time find state is executed with an instance of main page, we're just ignoring both the arguments, and we're just making an instance of the subclass of good state, which is main page good state. So now we're going to do Defmethod. We don't need any special headers. We do need a special body, our own specialized version of body, and we do need our own CSS. So we're going to do Defmethod, just page body with page main page, and in the instance that it's good, we're going to do state main page good state, and we're going to put h1 hello, I am main page in main page good state. Oh, can't forget that. Ooh, don't like it when I do that, or whatever. Oh, I don't ever have a clue how to undo that. Anyway, whatever. Defmethod page CSS, making sure to remember append page main page state main page good state, and we return a list. We're going to change the font. Oh, font color on body to red. Now let's go back to our handlers. Now let's see how in our handlers do we create that new page and have that page displayed. So we do let, probably let star in this case. We do page make instance main page, and then we do state find state page, and then display page with page and state. And hopefully it's not completely broken. Hello, I am main page in main page good state. However, our back, we have not compiled this. Oh, there we are. Now where is our CSS? Font color red. Well, our font color is not looking very red, so that probably means I did the font's color wrong. But we know background works, so we will just... Ooh, let's go to pages. We will just change HTML, and we'll rechange that. Refresh. And now our background color is red. You see? Now we have, this is what we need to create a new page, and we can customize. Basically, if we need to add more headers, that's what the around method calls next method. So we could do a page header and we could add more headers. Obviously we have our page body. We could make our failed state version, which we will do in another video, because you know, say you're trying to join an online game and you put the password in wrong. Well, now you're in a bad state, right? You can't display the correct page because the user has entered something wrong, and so you don't just have to specialize good state, you've got to specialize bad state. But yeah, I think as our skeleton goes, it's pretty good. So we will add our HTML protocol file handlers. Actually, I think we need file pages first. And there we are. Let's version bump it as well. That I hope you find useful, and I hope my explanations were useful to you, because a lot of these, especially if all you've ever done is message passing, like an object-oriented, this idea of generics and different ways of combining methods is, you know, it's a bit weird to people. So yeah, thank you very much. Hope this was helpful to you.